Everyone. This is for lesson 3. It's going to be page 47 in your book, and this is our due now for today. So if you were not in class, make sure you do them first before you just pause. And then for the learning targets, it's going to be here. We're going to be understanding the form in which quadratic function is written, and that it can reveal different key characteristics. Remember, there are 3 forms, right? We're going to learn about the third one today. And also, we're going to be writing quadratic equations in vertex form and factored form. So again, factored form should sound very familiar to you, but vertex is the new one that we're going to be learning today. So just briefly over here, it says to write the axis of symmetry, given the function, given the equation. Sorry, it's a bit messy here. I give you the factored form here and the standard form here as well. So you have to first determine, is it factored or is it standard? We haven't used vertex yet. We haven't learned that yet, so that's why it's not in here. All right, and you're like, well, this one has the x squared in here and it has no parentheses, so it has to be standard form. All right, so in this case, we're going to need the a's and the b's, the a and the b's to give us our AOS. So that's why we just define it right here. I kind of color work coordinated it. The a is going to come from that first part, the coefficient of the x squared, and the b is going to be the coefficient of the x, and we're just going to plug that in. So the work is right here on the right hand side. X equal to negative, so the negative's right here. And what is b equal to? -4. This negative has nothing to do with the b. Okay, so that's why it's 2 separate. Okay, and then 2, and then it's over 2, and this is always going to be 2 times -3. So the -3 comes from the a, which we said was -3, right? And then you're just going to do some math, right? And then you're going to simplify it. It's going to be 4 over -6, which reduces down to -2/3. Okay, so remember, we want to write our answer. Our AOS is always as an equation. X equals -2/3, right? And then same thing for number 2. Number 2, if you notice right here, it is, if you need to look in your book, because it's a little bit messy. It is, there are 2 parentheses there. So that's a really good indication that that is going to be in factored form. All right. The other thing that you need to notice, we do need to know the roots for this one. So it is just going to be 1 and -2. And how do we get -2 out of this? Because remember, originally, if you look over here, this is x minus. That's how it's supposed to be in the formula, right? Which means just the number, that's going to be the root. And when it's a plus, remember, it's normally supposed to be a minus. The only way that could be a plus is if this was like x minus a -2. And that's how we know that the root is a -2. All right. And then we're just going to solve that. Yes, so the work for here is down here. That's going to be x equals 1 plus -2 over 2, right? We got the 2 roots, add them together, divided by 2. And you're going to get x equal to -1/2. If you put -0.5, that is okay too. And then for the third one, again, this is going to be in standard form because there are no parentheses in here, so which means that's standard form. And if you look right here, I'm just defining what a, b's, and c's are. So the a is the -1, is the coefficient of x squared. And then b is 0, because if you notice right here, there is no x. If there's no x, that means the coefficient cannot be 1, because 1 times x is x. And we should still see an x, but we don't. So that means that the coefficient is 0, because 0 times x is 0, and that's why we don't see it here. Okay, and that's going to be, the c is equal to 3. We don't technically need this c right now, but we're just saying what it is. And then we're going to plug it into the equation just right here. So remember, that's going to be -b, so -0 divided by 2a. 0 divided by -2, which we know is just x equals to 0, right? So there we go. And we're going to move down. So now you're going to flip your page over to page 62, right? We're skipping all that transformation stuff. We're not going to learn that this time around. And if you notice right here, just take your highlighter, you're going to highlight this part right here. This is what we call the vertex form. This is the third form, all right? If you look at the title right here, vertex form of a quadratic function, that would also tell you too. So this is called the vertex form here. Vertex is going to be HK, all right? If you notice right here, that's going to be this H and this K, all right? And that's how that's what the vertex, and what do you think the vertex form tells you? The vertex, and that's why we call it the vertex form. Right? And so H, what does the H represent? That is, of course, going to be the x coordinate of the vertex, right? The x part, which also tells you the AOS. Okay, that's also the AOS. And the K right here, K is going to tell you, of course, the y coordinate of the vertex, and that y coordinate of the vertex. Remember, the vertex is either the highest or the lowest part, of the parabola. So that's also going to give you the min or max value. Okay. And let's see here. And what key characteristics? So you can kind of tell what you can see here. What key characteristics can you determine directly from the quadratic function when it's written? So there's no calculations needed just by looking at it. What can you see? Excuse me. Well, you can see the H represents the AOS, right? That is the AOS, because remember, that's the X part. So that tells you where that AOS is. The vertex, obviously, because it's the vertex form. So the HK tells you what the vertex, and also the A, that tells you the concavity, right? So that's going to tell you the up or the down. So that A is right here, the front, just like the two other forms. That A is the same A. Okay, those are all the same A. They're all the same. Okay, so we're going to go on to the next part right here. So if you notice right here, we have these 5 kids who wrote down their work. They're trying to, it says they're writing a quadratic function that represents a parabola that opens up. Okay, so we're thinking it has to open up. So, and also that the vertex is -6, -4. And notice I color coordinated here. So our opens up thing right here, that is going to be matching with our, I should go this. So this open upward, remember that's our positive. This is what we did here. It does have to be positives for it to open up. And notice right here for now, A could be anything. As long as it's positive, we're good. And you notice for Simone, Teresa, and Erica, they all did that. It's all positive. And also for Jesse, so that was the thing that was wrong with Jesse's, that it was a negative instead of a positive. Because if it's negative, it's going to open down. Okay, and when I say it, I mean that negative, the negative A. Also, the vertex is going to, if you notice right here, excuse me, for the vertex, this is going to be -6. So notice right here, it says +6. So I don't know if you looked up here. Notice, remember right here, it is x minus h, which means it's supposed to be a minus, just like our factored form. So it's very similar to that. All right, so it's going to be x minus a -6. If I just write it right here, just this color. So x minus a -6, and that's y. And if we simplify that, that minus negative just becomes, it's the same thing as a plus. If you're taking away negatives, you're adding to it. You're making it bigger. You're taking away negatives. All right, so we just rewrite that as a plus instead of saying minus negative. All right, and you notice all of these are pluses. Okay, and then so Jesse got that part right. But here, Leon, as I like to say, Leon did not get that right. He wrote a minus instead of doing a plus. So just take note of that, as well as right here. In the purple, you see the -4 as the y coordinate of the vertex. And notice it is right here at the end. -4 or -4, you can say. -4, -4. Leon also got that part right too. So he wasn't completely off. It was just one little thing, right? And I did this in class. I did use different numbers for different classes, but if you were to write an equation that was open down and the vertex was at 5, -100, what would that be, right? And then a lot of people had said, so they know that this is going to be negative. The A has to be negative because it's open down, right? Sad face. Tears. Okay, and then so you could pick -2, it could be -1, it could be -1 million, it doesn't matter, as long as it's negative. For now, A can be whatever number. We will soon, pretty soon, actually later in this video, talk about how to find that A, okay, and what A specifically has to be. And then here we go, it's x minus, right, because that's part of the thing. And then we have a 5, that's our x coordinate right here. And then we have the -100. Notice that this is exactly the same as our vertex. We don't do the opposite or anything like that, right? Because if you remember up here in the original, this is originally a plus. It is not originally a minus. It's the minuses that mess us up. If it's originally a plus, it's just that. Or you could, if you wrote plus -100, that would be fine too. But normally when we do plus -100, right? If it's like, okay, I'm just gonna write it here. x minus 5 squared plus negative 100, right? Adding negatives, that's the same thing as subtracting because you will still get smaller, okay? So those are the same. All right, so we're going to move on to the next page. Again, we're going to be using technology, meaning Desmos or graphing calculator or whatever graphing utility that you have to graph this. And if you guys remember, we're going to be getting the vertex, right? It says vertex right here, getting the vertex and the zeros off of the graph, okay? Later on, you can do this without using a graph. You can just, without using Desmos, you can do it all by hand. But for now, we're just trying to get conceptually how to do this. So that we're just trying to get familiar with the three forms, okay? We're gonna get them from the graph. All right, so if you notice here, A is 1 because notice there's nothing there, like that's why it's purple, nothing there, which means that there's that invisible 1 there, all right? And so we're gonna go and do some graph work. So I'm gonna go again to Canvas. I'm gonna go over to, let's see, modules. And again, for you guys, if you want to use this, you can use this at any time. I would just recommend if you're using it on a quiz or anything like that to have 2 Canvas pages open and one being Desmos and the other being your quiz. My recommendation. All right, and then so we're going to go Desmos calculator or just go to the website, desmos.com. Right, and then we're going to put in, it was x squared. Notice I put 2 x's. That x times x means x squared. That's just me being lazy. Minus 8x plus 12. All right, you don't need to put a y equals, but you can if you want to. See, y equals, same thing. All right, so if you notice right here, this roots we have are 2 and 6, and our vertex is 4, negative 4. Remember, you can just click on it and you can drag it, you know, so you can see other parts of it. Let's say if you can't, if it was like this, I was like, oh, wait, where is it? And I was like, oh, okay, I gotta just drag it. So that's all you need to do. So again, that was 2, 6, and 4, negative 4. All right, 2, 6, 4, negative 4. Let's go. Oh, look, I forgot. I already wrote it in. Right, so we wrote those in like that. And then we need to write it in vertex form. Remember, they do name it for you already. The function is already the h function. Okay, so h of x. So we're using that exact same one. So this is also h of x, because remember, it represents the exact same equation, the exact same graph, just different form. It just looks different. Okay, so remember our a we're going to get from the standard form, right? Remember, like all the a's, the standard form one, as well as, where's my mouse? Oh, there's my mouse. As well as the vertex. All these a's represent the exact same number. Okay, so they should not be different. So if you're just changing forms, this number in the front should stay the same. If it's different, you did something wrong. It's an easy way to check it. Right, so I put a number 1 there. You don't need to put a number 1 there. If you on the test, I'm going to know that that's okay. It's not going to be on this test, but on the next test, if you don't put a 1 there, I'm assuming that you know that that's a 1. Okay, and then we have parentheses, x minus, right? And then we're going to put the 4, which is that x coordinate. That's why they're both green. And then plus negative or just minus 4. Okay, and then that's the vertex form. That. Same thing with this number 2, the zeros right here. We got the zeros. For factor form, we need the zeros. We don't, for factored form, we do not plug in the vertices, okay? Because factor form always has to deal with the roots, okay? Always the roots. So we found our roots to be 2, 6. So that's why, again, we have a 1 for the a, because remember the a, same thing, mismo, right? All the same. And then so that's going to be x minus, because that's how we go, x minus, and then it's our R1. Well, what's our R1? It could be 2 or 6. It honestly does not matter. Okay, it's up to you. As long as you have both of them in there, you're fine. Okay, so I just picked the first one to put in here, 2, and then the 6. Notice it says x minus 2, not x plus 2. All right, so that's how you get factored form. Make sure you practice these ones. I'm going to write in the answers in here. For the first one, just when you graph it, you're going to use Desmos again. And you get your vertex to be 1.5 and 24.5, and your zeros to be -2 and 5, right? And remember here we did R of x, OF, R of x, because it already says right here, it's already stated that our function is going to be called, is R, okay? And then how do I get this to be -2? Remember we said that it follows that same A. The A's got to be the same. So here we have -2. That's what we have, that -2 there. So let me see if I can maybe do some same colorings to make this the same. Okay, so I use lavender for that. So this is going to be -2 right here. So this is going to be -2 right here. Okay, same thing with this factor form. That's also going to be -2. All right. And once we have that, we have also our vertex. Right, vertex we used green. So I'm going to use, I think it was this green. Nope, it was not that green. This one. All right, so for our vertex, we used for the x-coordinate, it was the 1.5 right here. So again, we have 1.5 right here. All right. And then for our y-coordinate, it was this blue. So we're going to click on that. And so for y-coordinate is 24.5. And here, remember, this is a plus 24.5. We do include that in there. Okay. So if this is positive, this should be a plus. If it's a negative, then it should be a minus. Okay, that one follows suit. It's just the stuff inside the parentheses that messes it up. Those are always like x minus something or whatever. Like it's always the x's. There are always problems with our x's. All right, so then for our roots, I'm going to try and see if we can get these same colors again. So for our roots, we have this green color, this green color. And so here we have a -2 right here for our roots. So again, right here, this is our -2. And notice right here, I wrote x minus the -2, okay? And so that's where you would see that -2. And remember, it does simplify to minus negative simplifies to a plus. So ultimately, I want you to get to a point where you just go x plus 2, all right? And then the other one is going to be that 6 right, or not the 6, the 5 right here. So that's the other root. You will see the 5 right here, all right? So that's how you write the factored form. Again, we did this one in class. We found the vertex to be -2, 4, as well as the zeros being -4, 0. You just plug it in just like how we normally would, right? So take a look at it, see if you got the right one. The only one we need to do right here is going to be the last one. I did not do that actually. So our vertex and our zeros, what could they be? If you haven't done it yet, you should pause. All right, so it's going to be 3x squared minus 3. Okay, I technically didn't do that, so I'll do that right now. Was it minus 3? 3x squared minus 3, yep. Okay, so here we go. So we have our our vertex is going to be 0, -3, and our x and y is going to be -1, 1. So this is our vertex, -1, 1, and then, oh, just kidding. That's our 0, so -1, 0, and 1, 0. And then our vertex is going to be, I totally forgot, 0, -3. Okay, so 0, -3. All right, and again, our vertex form, we're going to just copy this down. This is a c of x. So we're going to write down c of x just like this is equal to, our a is 3 right here, 3. So it's going to be 3 times x minus, and our vertex is 0. So I'm going to put 0 squared plus, oh, actually not plus, it's going to be -3. That's going to be your vertex form. If honestly you write this because you're like, well, x minus 0, can't you just simplify that? And I'm like, yeah, you can. But we can, I would prefer that you leave it like this, just so that it's very clear that it is vertex form, because if we don't, look what happens. So then you're like, well, could I have just done it that way? Yeah, I guess you could have just added it, but we didn't know, right? So now we know. All right, and then so for the last one, factored form, again, my mouse is lost now. Okay, here it is. So c of x is equal to 3. Remember that a is the same. And then we're going to have x minus the -1, and x minus 1. Let me just write that a little bit nicer, and then go 3, x plus 1, x minus 1. Okay, okay. Just like that. If you could get straight to here right away and you don't have to do like those minus negatives, please do that. Okay, I'm just trying to be clear. All right, moving on. Moving on again. Okay, so we're here again, number 6. We're going to identify each of the quadratic functions as either general, factored, or vertex. If you say standard, that's fine too. And then we're going to state all the things that we know. So first one, we had said that this was vertex. Somebody had said in one of the classes that, oh, because of there's a parentheses and there's where that 2 is placed, right? So that 2 is that exponent. That's how you clearly know, yes, it's in vertex form, all right? And for this one right here, let me finish this first. So in vertex form, remember, like we said earlier in the video and earlier in the lesson, right? We know for vertex form, we know A, whether it opens up or down, right? And we also know the vertex, right? As well as the AOS, because if you know the vertex, you know the AOS, because AOS is just that X part, and we know where it's located, right? That axis of symmetry. All right, same thing here. This is now, I noticed that there's just X squared and an X, which that means no parentheses, that means standard form, okay? And notice right here, the X squared comes first, and then it's the X. So basically to say if we had something like 4X plus X squared, like this is not written in standard form. It's written in no form. It needs to be, how do we write in standard form? You put the one with the highest exponent first, okay? So this one would have to go first, just so that you know. All right, so now with standard form, there's not a lot that we can know. There's some computations we would have to do, but just off the bat, we know A again. For all of them, we should know that A, right? And that tells us the concavity, whether it opens up or opens down. And also the C tells us the y-intercept. Remember, when the X is 0, so 2, 0, boom, boom, that means whatever's left, that's going to be the y-intercept. All right, in this case, it is 0 because there's actually nothing there. So what would that be? It has to be 0. It can't be 1, because then that changes the value, right? But it's plus 0. All right, so for this one, this is going to be, what is it? We got these 2 parentheses going on. This is definitely factored form. So factored form. And what does it easily tell us? Remember, it's the A. Again, we know the A, right? Because that tells us the concavity. So the opens up or opens down. I don't know why I wrote all that, but, and also we know the roots. So we know the roots, i.e. x-intercept, i.e. zeros, okay? All those mean the same thing, all right? So those are the things that we do know. Just right off the bat. Could we get the AOS and the vertex? Yeah, we could, but that would require some calculations. So this is just talking about just face value, what can we see, right? And then here again, this is, well, technically, I guess we could say that this is like vertex form, but we're just gonna call it the standard form. So this is standard form or general form. General form is fine too. And again, it tells you all this stuff right here, okay? And so this is the new stuff that, now this is finally the A. This is how you figure out the A. All right, so this is a worked example. I always like these worked examples because that you could kind of see like what they're doing, right? So the question is, write an equation for a quadratic function with vertex 1, -2. Okay, so this is important, 1, -2, that passes through the point 0, 1. So we know for sure it's passing through the point 0, 1. And this is where you can't just have any random old A, okay? You need to have a specific A, all right? So here it is. So they wrote down first, I like the left-hand side. It says, substitute the coordinates of the vertex into the vertex form of the quadratic function. Now, why in the world would we choose the vertex form? Because we know the vertex, right? If you know the vertex, choose the vertex form, right? Like you wouldn't want to put it in standard form. Like standard form doesn't tell you the vertex. Well, not easily, right? So that, there we go. So y, so this is the actual vertex form, y equals a times x minus h squared plus x. So here they put it in. Here's that 1, right? Just that 1 right there. Let me just see if I could. So the 1 right here, just like that. And then here is my -2, -2, just like that. Okay, now A, they just put in A because we don't know what A is. Okay, so we're just putting A because that's still our unknown. Okay, now we also know some more things. Okay, the other things that we do know, I'm gonna make them yellow and I'm gonna make it orange. Okay, so the one things that we do know is that it goes through this point 0, 1, right? And if you notice 0, so we're just plugging it in. Okay, we know the equation, so we're plugging it in. So we're gonna plug in 0 here, and then we're gonna plug in the 1 for y. So wherever you see the y, which is just one place, that's where you're gonna plug it in. So now we have one variable that we don't know, and we have everything else is numbers. So, and we have one equation, so we could totally solve this, okay? So there we go. And it said over here, substitute the coordinates of the other point of the graph for the x and y, which is what we did. And here we go. Let's try this out. And let's see, it says solve for the value of a. So if you notice right here, they did parentheses first, right? So 0 minus 1 is -1 squared, right? And then from there, what do? Oh, well, -1 squared is 1. That's where they have the 1. And then they multiply that. Multiplication comes after that. So a times 1, a. All right, and then from here, if y'all don't know how to do this, so +2, add 2 on both sides, and then you would get this 3 right here. All right, and that would be your a. That doesn't mean you're done yet. You just got to plug it back in. So it says rewrite the equation in vertex form, substituting the vertex and the value of a. So we've already substituted the vertex because we did that before already. Now all we need to do is just plug in this a right here, this 3 in here. And then now you have the equation. Now you know what a is. That's how you do that, okay? Just like that. Okay, so we're gonna take a look at Dawson and David's work. Or sorry, not David, Dave's work. So again, both of these have this thumbs up. That means that there should be no mistakes in there. If we do find a mistake, that means the book has a typo, which has been known to have sometimes. So let's take a look at it. So we do know, so this person wrote it in what form? Yep, vertex form. So let's just check just to make sure. So remember the vertex here is -1, right? Because this is normally supposed to be a minus. So -1, -3. So if you look over here, -1, 1 to the left and 3 down, yep, that's the vertex right here. So this is -1, -3. So looks like Dawson is doing a good job there. He wrote down A because we don't know what that is. That's what we're trying to figure out, right? And so let's keep on going right here. So it looks like they picked the point 1, 0. How do I know that? Because X is for 1, and they put 0 in for, right? 0 in for the Y. And if you notice right here, 1, 0 is definitely a point on the line. So literally you could pick any point on the line. You could have picked this point right here, -4, +4. But they're just choosing to do, what is it? Well, Dawson is choosing to do 1, 0, right? I'm gonna just erase that point right there. Now moving on. All right, so they picked that, the 1, 0 right here. They plugged it in, 1, 0, X and Y. And then looks like, let's see, 1 plus 1, we've got to do order of operations first, right? So 1 plus 1 is 2, and 2 squared is 4. Like, okay, that's how they got the 4. And then they tacked on this -3. All right. Well, then what do we do from there? Well, we add 3 to both sides. That's how they got 3 here. And then there was that 4. And how to get rid of that 4? Remember, they're multiplying. They're close to each other like that. That means they're multiplying. And then we would just divide both sides by 4. So that's how we get A is equal to 3/4. They just swapped it. Okay, so A is equal to 3/4. So now Dawson just plugged it right back in. So here's your 3/4 here, 3/4 in the A position, and then everything else is the same as what they did before. Okay, so now let's take a look at Dave. So it looks like he's using factored form. So he has X. So remember the factored form talks about the roots, and we know the roots are here at, one of them is at -3, the other one is here at 1, right? So -3, so X minus a -3, which is the same thing as plus, and X minus 1, the root is 1. Okay, so we're good here. So now it looks like they're, instead, for the X's, they're using -1 and -3. Ooh, look at that. They're using each other's points. It's basically what they're doing, it looks like, right? And so what we're gonna do here is we're gonna just solve for them. Oh, so let me just write down the point. They're using the point -1, -3. Okay, so for all the X's, there's only 2 X's here, or 2 X's, not just only. So make sure you plug in -1 for both X's. All right, and so we're gonna do order of operations. So parentheses come first. -1 plus 3 is 2. -1 minus 1 is not 0, right? -1 minus 1, you could even check on a calculator. I'm telling you, it is -2. And then 2 times -2 is -4, right? That's how they're getting all this. Divide by -4. Oh, phew. They're getting the same A, because if they got a different A, that means one of them is wrong, and that means the book is wrong. We don't want that. All right, so yep, A is 3/4, which is exactly the same thing as this. And if you notice right here, yeah, the A's are the same. Yes, we verified that the roots is that, and this is the vertex. it is equal. And if you want to go on Desmos and see if they are the same, they should overlap right on top of each other. All right, go and do that. All right, so this is the last part right here. So now let's do some practice. Okay, so if you want to pause and try these things, or like, and then you can pause after every problem if you want to. It would be better than you just listen to me the whole time and going and be like, and after it's done, it's like, okay, what? So you need to actually do a thing. All right, so here we go. So write an equation for a quadratic function in vertex form. So this is giving us a hint in vertex form with vertex 3, 1 and pass through the point 1, 9. Okay, so let's see, we got this. All right, so vertex form, I'm gonna just write vertex form over here just as a reminder. Boom, f of x, because that's pretty general, is equal to, or should I just do y because we're just gonna use y anyways? Yep, that's what we'll do. So y equals a times x minus h squared plus k. Sorry, maybe I'm sad. I'm writing down. All right, I'm not sad. So remember, this is h, this is k, and we will do the thing. So y is equal to a, because we remember we don't know what a is, and that's what we're trying to figure out, times x minus, and h is the 3 squared plus 1. Okay, that's that one right there. And I'm going to do some colors again for you, just so that's the 3. Come on. That's the 1. It's the 1. Okay, so that's where that is. Right now we're going to just plug them in. Right, we're going to plug in the other point. So we're going to plug in, what are we going to plug in for the y? The other point. Okay, not the vertex. Okay, because we already put that information in there. Okay, so what we're going to do is we're going to plug in the point because it needs to go through this point as well. Because we already know it goes through the vertex because that's what we're making it. So we have to put in the other point. So in for the y, we're going to put in the 9. Right, that's going to be this number right here. And then equals a, we still don't know a, times x. We'll make that this color. We'll go 1. So it's going to be 1 minus 3 squared plus 1. Just like that. And if I had more room, and I wish they would have given us more room, but they didn't. So we'll work with it. So now we're just going to solve this. Okay. So now that we've plugged everything in, I'm going to just put a little arrow like this to show. We're going to do order of operations first. So it's going to be 9 is equal to a times, oh my goodness, my 9 and my a's look the same. 1 minus 3, that's going to be negative 2 squared plus 1. And then so 9 is equal to a, oh, actually, let me just erase that. Because actually, what is that? Negative 2 squared, which is going to be 4. So I'm just going to put the 4 in front. So that equals 4a plus 1. What do I do from there? So guys, if you like to show your work like this, just go minus 1. And that is going to be lots of arrows here. 9 minus 1 is 8 equals 4a. Almost there. So we're just going to divide both sides by 4. I divide by 4, divide by 4. And that's going to be a is equal to 2. All right, so now all we need, we're not done. Don't just say, oh, well, I'm done. I found a. We need to plug it back in. So we're going to say y is equal to, what is it? Y is equal to 2. Remember now, we know what the a is. So it's 2 times x minus 3 squared plus 1. Now we know our function. Okay, that's what it's going to equal. And just for you to verify, so 2 minus 3 plus 1. We're going to see if that's true. So 2 minus 3. Okay, this one I actually have to do the caret. Okay, plus 2. Make sure if you do that, you have to like arrow out of that. Plus 1. Plus 1? Plus 4? Plus 1? Let me go see again. Minus 3 plus 1. 2 minus 3 plus, okay, yep. And if we notice right here, our vertex is at 3, 1, which, yep, 3, 1. And it needs to go through the point 1, 9. So we're going to go, there's this 1, and we're going to go all, oh, don't do 1 9. Oh, there it is. 1 9, just like that. We did it. That's one way to check. And it's kind of hard to get to these points because it literally gives you all the points here. So you kind of have to be really careful about it and like slowly do it, okay, to be able to check. All right, good. Happy days. We're going to do the next ones. If you did not do it yet, pause. Do it. All right, so again, this one is going to be in factored form with zeros at -4 and 0, and then passes through the point -3, 6. So we're going to do the exact same thing here. So y is equal to, let's see here, factored form that we don't know a again, times x minus, remember it's going to be -4. So I'm going to go, let's see if we can do it this way. Oh no, let's do it. So -4, that's another way to do it if you want to. And then times x minus, that's going to be 0. 0 was my other color. Let's do this color. All right, so that's going to be 0. All right, then from there, remember what we do? It says pass through the point, -3, 6. We're going to plug this point into the equation, okay? We already know the x and the y. So the y, we're going to start out with the y because that's what this starts out with. So y for us is going to be this 6 right here. So it's going to be 6 is equal to a times x plus 4. Oh, I'm going to go back and figure that out. Don't worry. Okay, so use my eraser right here. Oh, erased too much. Put that parentheses back in there. And then I'm going to use, let's see here, my orange color. So that's going to be this right here, this -3. That's right here. That goes into the x's. So we literally erase the x's, and we're going to put in the -3. All right, so now we're using order of operations to do the rest of the stuff. So I'm going to say 6 is equal to a times, and a -3 plus 1 is, -3 plus 4 is 1, right? Times -3 minus 0 is just -3, right? And then what do we get? We're drawing that arrow right up there, and it's going to be 6 is equal to 1 times -3 is just -3a. All right, almost there. How do we get rid of that -3? Remember, we have to divide it, right? So we're dividing by -3 on both sides, right? You're like, oh yeah, it's coming back. A is equal to -2. Negativo dos. All right, so we're now going to plug it into the equation. So y is equal to, right? It's going to be -2 parentheses x plus 4. Okay, technically x minus 0, you're right. We can simplify this down to x. So I'm just going to write it right here. Okay. All right, next one. Write an equation for a quadratic function in vertex form, right? Telling us when we have the vertex of -1, 6 and pass through the points -3, 4. Literally, if you have not stopped us yet and you have not tried it by yourself, please do it right now. Okay, so now we're going to try this again. So now that you've unpaused it, because you've already done it, right? So y is equal to a times x minus a -1 squared plus 6. If you didn't see what I just did there, you should take a look, rewind that just again. Okay, and then so we're going to plug in the other equation, other point. So that's going to be 4 is equal to a times -3 plus 1. Oh, don't forget the square, plus 6. Okay, remember the -3 is the x part and the 4 is the y part. All right, and then we're just going to do some more calculations. So we have 4 is equal to -3 plus 1 is 2. 2 squared is 4. Just did it in my noggin. So 4a plus 6. Okay, and if you want to skip it, like skip a couple of steps like that, that's perfectly fine. We're in algebra 2. Okay, I'm going to assume that you know how to solve for x, and if you don't, you should review that. All right, and if you want to write out all the steps, that's fine too. Either way is okay, but just don't write a is equal to 5, and there's no work. Like like, I don't know where you're getting that 5. So make sure you do show your work, just you can skip some of the steps. You don't have to like do every single one if you can do it in your head. Okay, so now we're gonna just subtract 6 on both sides. Gotta get rid of those adding stuff first. So it's gonna be 4 minus 6, which is -2, equals 4a, and I'm so close. And then so let me just rewrite that here, is equal to 4a. Divide both sides by 4, and you got a is equal to -1/2. Okay, where did I get -1/2? Remember 2 over 4? 2 out of 4 things, that's half. If you eat 2 out of 4 pizzas, you ate half the pizzas. You gotta lay low, man. I'm just kidding. All right, we're not done yet. We're not done yet. No time for playing around. We gotta do this. So y is equal to -1/2, that's the a. And remember, this in vertex form is x plus 1 squared plus 6. Boom, just like that. Last one. All right, so now, oh, well, look at this now. We have an actual graph, right? And it says to write it in, it says vertex form. This is gonna be fun. And this is given the graph of g of x. Okay, so now we know what to call it. It has to be g of x, because that's what we're referring to. So I'm gonna write it over here. Okay, this is gonna be a little, okay, you guys write it over here. I'm gonna write it over here, okay, because it's a little weird to write across like that. All right, so for g of x, what do we know? Okay, we don't know the a, but we know that it is in vertex form. So it's gonna be x minus something, x minus, and what is our vertex? Well, we need to find it. So we go, well, vertex, where are you? It's the lowest point. Okay, so it's right here, at this point right here, and I'm gonna just, it's gonna be x is first, so it's 4, and that's -5. So it's 4, -5. That's a vertex. So we're gonna just plug that right in. So 4 is the x part, squared, and then -5. Okay, so all we need to do later is just figure out what this a is. Actually, the later is right now. We're gonna figure out what that a is. So literally, we need to find any point on here. Sorry if I get a little big. I'm just trying to look for a point. Okay, this looks like it's a good point that I can use. I'm gonna use this point right here. Literally, you could use this point right here, or this one. Just find a nice point that's pretty accurate. This one, it's kind of hard to tell where it is. I want to say this one right, 2.7, but it's kind of hard to tell, so I'm just gonna use this one. This is the safest one for me. So I'm gonna use this point right here, which is, what is it called? 3, -2. I know it has to go through that point, 100%. If you want to try another point, you can do it. Actually, we might do that just to see if it works, right? And then let's plug this in. Remember I said g of x, that represents y, okay? G of x is just like to be more specific, like, oh, we're talking about this specific function here, and y is kind of the more generic. All right, so we're gonna put in the -2 here for the g of x, and a, we still don't know, that's the thing we're trying to figure out, and x is the 3. So 3 minus 4 squared minus 5. And so this is going to be -2. So 3 minus 4, -1. -1 squared is 1. So it's just going to be a minus 5. You need that one more time? Let me just try that one more time. So -2 is equal to a times -1 squared minus 5, right? But remember this negative, what's that going to be? So -2, a, and then what's -1 squared? It's literally -1 times -1, which is 1 times 1. This is times minus 5. Well, what's a times 1? A. That's why I got that. Okay, anyways, going back to this, now we're going to add 5 to both sides, because remember, we're trying to get a by itself to figure out what in the world that could be, right? And that has to be 3 is equal to a. Okay, so now we're just going to plug it in. So we're saying g of x is equal to 3 times x minus 4 squared minus 5. Whoa. Okay, so honestly, if you try another point, it will work out for you. Let me just do it over here really quickly. You don't have to do this. You can just see if it works, right? And we're going to try this point right here, and that's going to be 5, -2. If it gives us a different answer, if it gives us a different a, I did something wrong. You didn't stop me. We don't want that. So we're going to try this out. So this is -2 is equal to, I'm just copying this down over here, a times, what is our x going to be? 5. 5 minus 4 squared minus 5. And we'll look at this. What? 5 minus 4 is 1. What's 1 squared? 1. 1 times a, 1. Oh, okay, sorry. 1 times a is not 1. 1 times a is a. You're like, wait a minute, Miss Lee, that's not it. Remember, we're adding 5 again, and then it's going to be 3 is equal to a. What? Same thing. Okay, do you see that? It's always going to give you the same thing. So if you're getting a different number, so on a test, any given test, I always, sometimes if I have some time, I like to do it 2 different ways just to see if I get the same answer. Because usually, if I get the same answer, then I'm pretty safe, unless I did the exact same mistake for both of them, which would be odd. Okay, so that's one way to check. I like to know that I'm sure on tests. I'm just saying. Okay, and that's pretty much it. So again, your homework, now you should be able to do your homework. Okay, now you should know where those A's came from. Because I know there was a couple of people on the homework review who were like, oh, how are they getting these fractions for A? This is how they're getting it. Okay, so go back and try it. Okay, now that you know, go back and try it. Okay, I'll see you later. Bye.